already I have talked to Sanjay Tripathi, other sections. Friday 6:30 will be there, 6:30 p.m. Okay, it's day after tomorrow. So last times we started the up to first module. This is the second module we are discussing. So last time we started the line configurations. In fact, we are discussing the characteristics of data link configurations. There are three characteristics are there: topology, duplexity, and line discipline. In topology, we have seen this. I mean, how the stations or the stations or the devices are physically arranged. Topology indicates that. I mean, it can be point-to-point links or it can be multi-point link that we have seen. In the point-to-point links, it's a direct connection easier, right? Suppose computer is connected to a terminals, then you see it is point-to-point links. But in case of multi-point links, the primary stations can be connected to more than one stations through the same mediums. Here the medium is shared by the different stations, and there will be one input-output port, right? So that is the multi-point links. And in case of duplexity, that indicates the direction of signal flow or timing of signal flow. In simplex, there are three types of duplexity is here. Duplexity is here. One is simplex transmissions, signal flow in one direction only, right? It only transmit a particular station, primary can transmit only but not receive. And in case of half duplex link, both the stations can transmit and receive, but one-way alternate. I mean, two-way alternate, two-way, not one-way, two-way alternate, right? But not simultaneous. That is the half duplex. And in case of full duplex link, the two stations can transmit simultaneously or receive simultaneously. That is the full duplex, and it is two-way simultaneous. So it will be different for different signaling schemes. For digital signaling, say if you consider through guided media, then half duplex requires only one communication path. One path is equal for half duplex. But for analog signalings, it depends on frequency, whether the guided or guided transmission or unguided transmission is used. It depends on the frequency. If a station transmits and receives on the same frequency used for transmission and reception by stations, then it must operate in half duplex. But if a station transmits on one frequency and receives on another frequency, then it may operate in full duplex in wireless transmission, and in full duplex also mode in with a single line for guided transmission. So these things you keep in mind. So analog signaling scheme, digital signaling schemes, these are different way of transmissions, right? Another thing is your characteristics of link configuration, that is the line discipline, which is the most important and is needed when you use the transmission link. The discipline is required, right? For say on half duplex line, only one station at a time should transmit. On either half duplex or full duplex line, station should only transmit if it knows that the intended receiver is prepared to receive. Then only the station should transmit. So these are the some disciplines are there. So these are implemented. You see, if you see the point-to-point link, how this discipline is implemented. You see it here. It is very simple for point-to-point link, but multi-point link it will be complex. Just if you consider the half duplex links, where any of the stations can initiate the exchange. I'm just showing the diagrams, it will be more clear. These disciplines. In fact, there are three phases are there: establishment, data transfer, and terminations. So see these diagrams. This is point-to-point link. And this is half duplex. Right. So this is station 1. Transport data to wants to transport data to station 2. So station 1 to station 2, right? And in that case, you see there are similarly if stations 2 also can transmit to station 2 to station 1. So in this case, there are 3 phases are there. This one, this one, this one. So solid line is a normal data transfer case. These ones, there can be some absurd things also is here. In that times, you see. Okay. So this is the first one, the establishment phase. The 3 phases is the establishment phase. Next is data transfer phase. Data transfer phase. Next is the termination phase. Termination phase. In the data transfer phase, you see, in the establishment station, say any of the stations can initiate the data exchange of data. There are 2 stations, station 1, station 2. Any of the station can initiate the exchange process. So one station, first say station 1, if it wants to transmit, it will first send an inquiry message, ENQ. This is ENQ. This message will be sent by the station 1. If the second station, stations 2, if it wants to receive, or if it is ready, then to receive this, receive the data, then it will send the positive acknowledgement. Right. So it will send the ACK. It will send the positive. It can respond or it can respond in on another way also. Just by considering, say, if it is ready to receive, then it will send the acknowledgement, right? So that means it is ready to receive. Next is the station 1, then send some data. You see, this is the data. So frame, this is the frame data. Data will be transmitted in the form of frames, right? The second station after, and it will pause after transmitting. The second station next acknowledges the successful receipt of the data, right? By sending this acknowledgement. It will send the acknowledgement ACK, send the acknowledgement for successful receipt of data. Then the first stations then sends the end of transmission message, EOT, end of terminations message, which terminates the exchange and returns to the initial state. This is the normal case. So the station 1 first transmits ENQ to know whether the station 2 is ready to receive the data. If it responds with the positive acknowledgement, then the station 1 will transmit the data, and when the data are successfully received, then the stations 2 will send the acknowledgement, and the station 1 can send the EOT for termination of the exchange of data, right? But there can be some other cases also there. Some other things are there. There can be invalid reply by the stations 2. Some abnormality can be there, that is invalid reply, or there can be negative acknowledgement. You see here, NAK. There can be negative acknowledgement, or there can be error ERP, error recovery procedure, error recovery ERP, right? So these things may be there. If negative acknowledgement NAK it is used by the stations 2, that indicates that the station 2 is not ready to receive the data, or data maybe that received, that data are in error, right? So that is the meaning of this negative element. In case say data is received, if it's in the negative element, can be sent by the stations to here or here. If it is here, then that means it is not ready to receive. If it is here, that means data are in error. Also, station may fail to respond, or respond with an invalid message. That is this ones, right? So this is the other cases, and you see these heavy lines. This heavy line that I've shown it. This indicates the normal sequence of the communications events. Now, if some unexpected event occurs, like say NAK or invalid reply, then NAK or invalid reply, then station 1 can retry its last action, or may use some error recovery procedure, ERP is the error recovery procedures. It may retry its last actions, or it may use ERP, error recovery procedure, right? So these things might happen also apart from the normal case. So there are 3 distinct phases I mentioned. Establishment, that means establishment phase. Here it determines the station, which station is to transmit and which station is to receive. That is decided in the establishment phase. In the data transfer phase, data are transferred in one or more acknowledged blocks, block by block. It can There can be one frame, there can be more subsequent frame also can be transmitted, but with the proper acknowledgement. So that is a data transfer phase. And in the terminations, see here, any of the stations can initiate the termination, right, by sending this EOT message. So if the line is full duplex, data and control message can be transmitted in the both directions. Here you see I am showing the station 1 to station 2, but if it is in the full duplex, then or the full duplex, then both the stations can transmit. Right, data and control message can be data other than data. Those are the control informations. So that would be exchanged in both directions. So in this case, one station is designated as a primary and the other one secondary. And generally primary initiates the exchange. Some protocols are there, we'll see it, high-level protocols. Secondary may initiate the data transfer. We'll see it, some exceptional cases are there. So protocols are there. This is the general protocols we are just discussing. So that is a point-to-point links. Now, if you consider the multi-point links, in this case, you see multi. It depends. In this case, the discipline, the line discipline depends on whether there is a designated primary station or not. Right. In this case, here you see the primary will send the data to the secondary, but I mean the data are exchanged between a primary and secondary, not between two secondaries. In case of multi-point links, one thing is there. First, primary should be identified, and data will be transferred from the primary to a secondary, but not between two secondaries. Right. There are different disciplines are there for multiple links. One commonly used, that is pole select discipline. One discipline that is used in multi-point link, it is pole and select. Pole and select. Pole means you see pole. What does it mean? Pole. Pole means primary request data from secondary. Primary requests data from a secondary. Right, that is the meaning of poles. And select, the meaning of the select control message. The select, you see, indicates that the primary, it has data to send and informs the secondary that data are coming. It has data to send. Right, that is the pole or select disciplines. If you see the diagrams, it will be more clear. There are also different phases are there. You see this is one case when no data exchange. Control information exchange, but no data exchange takes place. This is at the time T0. This is a station 1. This is station 1. Primary and secondary must be identified. So this is primary. This is secondary. So primary polls this message. Polls, right? And after some processing times, secondary may send the negative acknowledgement, NAK. Right. So in that case, there will be no data transfer. So pole terminals has nothing to say. Pole means you see, this is pole. I told you. Pole means primary is not sending data. It's not sending the data. Primary request data. Request secondary to send data. That is the meaning of pole. Right. So that is, so in this case it is the port terminal has nothing to send. Nothing to send. This is one. Another case you see it here. This is primary. This is secondary. So here you see primary poles message to the secondary. Right. You see that can be data transfer takes place if secondary response, data transfer will be there, and there will be acknowledgement will be there on the primary ACK. Right. But in this case, timing diagrams is most important. I'll just discuss it. So in this case, say this is T0, this is T1, this is T2, this is T3, this is T4, and this is T5. They are most important things. Must note it. So this is A, pole terminal has nothing to send. In this case, B, pole terminal has data sent, has data to send. Terminal has data to send, and there are two more cases are there. Select the poles select, and in this case, in some cases, this is desirables select. Select and acknowledgement ACK data acknowledgement. ACK, that is the select, using select, data transfer using select. This is C, select. Also, there is another case, that is a fast select, where the control information as well as data will be sent. Here it is fast select. Sometimes it is also very useful. Select plus data. Say select, let us say it is select plus data and acknowledgement ACK. Right, that is the case D, that is fast select. So one by one see it here. So in this case, you see first if this T0, T1, these are the most important things. So in this case, pole terminal has nothing to send. In that case, what is the timing, total time taken? Timing for this phase. This T0, first the process starts at T0, right? So the Tn, total times for this complete process, pulled, acknowledgement and received, then the Tn, total times Tn, that is, carefully just note it, T propagations. You see the time taken by the pole message to transmit from the primary to secondary. That is T propagations, right? Plus T poles. T, that is a transmission times, time to transmit a pole message. T poles, right? Plus T processings. Some processing time is required. You see, whenever the pole message is received, some time is required. So some to process these informations. So that is the processing times. So T processing times. Similarly, negative acknowledgement to transmit this one, it will take some times. That is T negative acknowledgement, NAK. T NAK negative acknowledgement plus. So if you consider this pole transmission time of the poles plus propagation time, similarly transmission time of the negative arrangement plus propagation time of negative arrangement. So that is T propagation. So there will be 2 propagation times, right? Now, what are those times? You see T propagation, that means what is this times? If you see the timing diagrams, so T propagations actually it is, you see, it is T1 minus T0. So it is T1 minus T0, T propagations. Next, you see if you say T poles, which is the transmission time of the poled masses, right? So that is actually T2 minus T1s, T2 minus T1. That is the transmission time of the poled masses, right? Next, you see the T processings. You see T processings. So T processings is the time to process the pole message before acknowledgement. Before acknowledgement, right? So you see it, some time is elapsed. So that is T3 minus T2. That is T processing times actually T3 minus T2. T3 minus T2. And what else left? T negative acknowledgement, T NAK, that is the time to transmit the negative acknowledgement. That is T4 minus T3. That is T4 minus T3. Right. So if you consider these things, then if you just put all those things, actually T propagations we are considering same for this and this, right? So you see it here. So TP, so right. So that is the case for these things. That is the case. I mean A. That is for case A. Now for case B, you see for in this case, so you see there will be 3 propagations: propagation for pole message, data, and acknowledgement. So in this case, TP will be thrice of T propagations. T propagations. In this case, actually two T propagations. In this case, 3 T propagations will be there. Other things will be same: T pole plus T acknowledgement. You say acknowledgement is here. TACK plus T data will be there. T data plus 2. You see, this is one processing times. This is another processing times. So 2 T processing times will be there. Have you followed or not? If you don't follow these two questions, you can ask. But they are the most important things. Then only you can understand that stop and error flow controls or error control things. Those things, timing diagrams will be there. But this is the basic things. If you have any questions, you can ask regarding these 2 equations. Anybody, if you have any questions, you can ask regarding these total times. Anyhow, if you do not follow, you can ask. These 2 timing diagrams is clear or not? You tell me. Anywhere, any doubt, you can ask. Anybody? Any terms? You see how many terms are there? 1, 2, 3, 4, 5. In this case, 1, 2, 3, 4, 5. In fact, here 3 key propagations are there. That is because of these three transfers are there: whole message transfer, data transfer, acknowledgement transfer. So that is the actually when data are actually transmitted here. Select and first select, there is special cases that we'll discuss later on. But first of all, whether these two equations are clear or not, say yes or no. Say yes or no. Anyone? Please respond. Unmute and tell me whether you have followed or not. Please respond. What's about done? अब सो गया क्या खाना खा के बाद? Unmute it and tell me whether or not.
Sir, followed, sir.
Okay. So these are the two basic equations. We'll see the when you consider the actual protocols, they are the outlines of disciplines, but actual protocols we'll see it. Stop and flow controls, stop and wait flow controls, protocols, sliding window flow controls. There are different protocols are there. Flow control, error control also there. These things, that times these equations will be more important. Then if you understand this one, then only you can solve those equations. Efficiency, actually you have to calculate the efficiency of those things. Anyway, so these things are, if it's clear, then you see for polling, you see polling, there are different kinds of pollings are there. One polling which is most common form of polling, it is actually roll call polling, that you know it. One polling scheme is roll call polling. Roll call polling, in this case, primary selectively polls each secondary. This is a multipoint link. I'm telling you, this is a complicated things. Here, the primary selectively polls each secondary in a predetermined sequence. Like say, it's more, and the simplest case, what happens? The primary polls each secondary in a round robin fashions. So there are say n stations are there, S1, S2, S3, like these things to Sn. Then it will poll the secondaries in a round robin fashions, and it will repeat the sequence. So the timing in this case, for if you consider round robin fashions, the total time in this case will be Tc, that it will be n Tn. That Tn we have seen it. You see the Tn total times NTNs plus KTD. That is actually TD is the TD that indicates the time to transfer data, right? So what TC, time for one complete polling cycles, time for one complete polling cycles. So there are n stations are there, and Tn is the average time to poll a secondary exclusive of data transfer. Exclusive of data transfer, that is Tn's, average times, right? And TD, time to transfer data. TD, that time that indicates the time to transfer data, right? So Tn and TD, these two are different. Tn, just we have seen it for polling a secondary, exclusive data transfer. N, the number of secondary stations, and K, N and K, something different is here. N, the total number of secondary stations, but N, the N, that is the number of stations, and K, the number of secondary stations that have data to send during the cycles. Right. So the key secondary stations, they actually involved in the data transfers out of n. So that's why k is less than n. So that is the roll call pollings. Well, you can see also there are select function is here. In that case, you see 4 separate transmissions are there. In this case, you see select message will be transmitted by the message transfer transmits by the P primary stations, and secondary when acknowledges. I mean, here select means primary has data to send, the secondary acknowledge it, then primary will send the data and it will be acknowledged successfully, or the data has been received successfully. So that is, there are 4 operations there. That is in the select functions. Also there can be fast select. Here you see these alternate techniques where select message includes the data to be transferred. Right. That's a select plus data. Right. So the first reply of secondary will indicate the station was prepared to receive, and in fact it has received the data successfully. So the first arrangement will be there. So that is the first. This is most important whenever short messages are required to transmit. Right. Short messages, when the messages are in the message blocks are short in frames, and the frame size is not too large, and in that case the transfer time also is not longer than the reply times. So in that case this fast select is very much useful. So that is the fast select. So select and fast select, you see something different is here, and this is very useful for transferring of short messages frequently. Right. That is one case. Another line discipline is here apart from this poll and select, that is contention. In that case, you see contention. Another discipline is here, contentions. In this mode, actually there will be no primary actually. Rather, there will be PR stations. PR stations will be there. We'll see in HDLC protocol, those things will be clear. PR stations, there will be no primary, secondary. The PR station, there will be PR stations only, and any of the station can transmit if the line is free. Right? Otherwise, it has to wait. This technique is very much useful for LAN, for local area networks, and also for satellite systems, satellite communications. Satellite systems. This contention discipline is most useful. Right? It has found widespread use in those cases, local area networks and satellite systems. So if you see all these multi-point line disciplines, one thing is most important, that is addressing. Addressing is most important. Right? You see, in case of roll call polling, we have seen this. There will be a station's primary, and it must indicate the intended secondary. Right. But in case of PR stations, you see PR stations, both transmitter and receiver must be identified. Right. So that is the difference between the roll call polling and the other cases. I mean, contention disciplines. Right. In that situations, both transmitter receiver must be identified. In this case, in case of PR situations, and there are 3 cases are there. So far we have discussed. In point-to-point case, the point-to-point link, no address is recorded because it is fixed. One station transmit, other station receive. Right. But in multi-point, primary secondary concept will be there. One address needed to identify the secondary, just now I mentioned. For peer multi-point, two addresses are required to identify transmitter and receiver. So this is for point-to-point, multi-point lines, multi-point link. One address needed to identify secondary, right? And if it is peer situations, multi-point peer, multi-point can be two types. You see, just where contention discipline is used. In that case, primary transmitter receivers should be identified, and in the roll call polling, you see one address is required to identify the secondary. So these are the things, these are the disciplines must keep in mind. Another polling is there that you should know also, that is called half polling. Half polling. So in that case, you see the terminal clusters are widely separated, right? There will be cluster of secondaries will be there. They are existed, you see, further from the primary. So that in that case, half polling is effective. If the terminals and the terminals clusters widely separated, then you see this half polling is most effective. In this case, you just see in the diagrams, half polling. So this is say primary, or the server. This is a primary, and the clusters of terminals or secondaries are there. You see. These ones. This is one directions. Next also here, this is one directions. This can be both directions, right? This is one directions. This can be both directions. So this is say station 1. This is station 2. This is station 3, right? So you see, in this case, each secondary connected to its nearest neighbors, right? And the central computer, it manages all transfers to and from secondaries, right? So in this case, say primary selects and sends data messages to any of the secondary at any times. You see, any of the secondary at any times. Primary can send selects and can send the data message, but to receive message from the secondary, there what will happen? Say the primary, that times the discipline is the primary sends to receive data from secondary. In that case, what happens? The primary sends a poll control message, poll information, that is a control message to the furthest secondary, right? To the furthest secondary. Then it responds, the secondary responds either by sending a data message, it can send a data message, or nothing to send the control message. It can send the data, or nothing to send the control message to the return line, not to the primary but to the nearest neighbor. You see, first it will primary sends the poll message to the furthest secondary. The secondary can have two options: either it can send data or nothing to send. So that is actually those are transmitted to the secondary return lines. These are the return lines, right? To its nearest neighbor. This the next secondary. This is in this case station 2 takes this poll message, and if it has a message waiting response by adding a it has a message, then it can add the it can has also options are there. So if it has data to send, then that will be added to the tail of the received message, and also that will be sent on the return lines. So in this way, it will continue from secondary to secondary, and each secondary at its own response message to the to the tail of this the original message, right? So and whole thing will be related to the primary, and on the receipt of this composite message, so there will be composite response. So the and in the primary there will be front end processor will be there. Front end processor will be there. So first the composite message is passed through this front end processor, which will disassemble the message, and if any valid data is here, that will be sent to the primary for further processing. Right. So what are the things are there? See, primary can select. I mean, it can send data message to any of the secondary, you see, but also it can receive message from the secondary. So for receiving this message, the primary sends the poll message. You know, poll means the secondary has data, the request data from secondary. So primary will send the poll message to the farthest secondary. The secondary can have options, it can send data, or there is no data to send. So whatever things are there, so that will be sent to the return lines to the nearest secondary. Secondary also do the same things, but that time this message will be added to the tail of the received message. So in this way, secondary to secondary will be the message will be relayed to the composite message will be relayed to the primary. But before entering the primary, it has been passed through the front end processor, which will disassemble the message, and if any valid data is here, then that will be sent to the primary for further processing. So that is the principle of half pollings. So these things are there. So what we have learned, there can be you see roll call. You see, this is the point-to-point links, or can be multi-point links. Multi-point links, it is a little bit complex. Here the discipline based on this poll and select polling, but also there will be contingent type discipline is here. Poll means request to data from secondary, select means it has data to send. So based on these things, there can be 4 categories are there, right? Poll and select, right? See, first case there is no data to send. The second case it has data to send. And second times it is there is no poll through using select. Also data transfer can take place, and also that can be operation can be reduced if you consider the fast select. The timing diagram I have mentioned. I think today this much. Next time we'll see the actual protocols, data link protocol. They are the basis of these things, and next we'll see the next time we'll see the data link control protocols. The actual protocol we'll see, that is top and wait flow controls. Then these things what I have discussed, these things will be timing diagram, etc. These times will be more clear. So if you have any questions, anybody can ask regarding these things. Any questions regarding these pollings or discipline, line disciplines, or duplicity or topology, anything? So if you have any questions, you can ask quick. Any questions? If you have any questions, you can ask.
No, sir. No, sir.
Okay.